Geometry Unit 1, Lesson 11. I can justify logical arguments or give a counterexample to disprove it. So, first vocabulary word we're going to look at is conditional statement. And a conditional statement is a logical statement that has a hypothesis and a conclusion. Okay, so now the thing here, hypothesis is going to be the first part, and our conclusion will be the second. And if we go for an example, we'll see what's going on. The key here is for the conditional statement to be true, it has to always be true. So let's look at an example. One conditional statement might be if you score below 60%, then you earn an F. So is that always true? If this hypothesis is met, is this conclusion here? Notice after the if, this is the hypothesis, and then the conclusion comes after the then. If this happens, is this always true? Yes. You get below a 60, you earned an F. So we can then talk about this, though, in terms of what a counterexample is. So a counterexample is an example that proves a conditional statement false. So, for example, I could rewrite this and say that if you passed the test, then you earned an A. So what would be an example that proves that false? I'll steal some room down here. An example, and I only need one, because it has to always be true if it's going to be true. You might say, well, you know, my counterexample, I could pass with a B. And that's all you need to say. One thing, and it proves my statement wrong, because I'm saying that that's always true. If you pass that test, then you always earned an A. And you're like, well, no, that's not true. Right here, my counterexample, I could pass with a B. Now, what about something that's biconditional? Bi means two, and what it really means is it can go two different ways. So an example would be this. Let's say, for the definition, what it means is a statement, so a conditional statement, and its converse. What's the converse? Well, the converse is when you reverse the hypothesis and the conclusion. Okay, so it's when a statement and its converse are both true. That's when you could say it's biconditional. So it's true both ways. Let's explain. So the converse here is when you reverse hypothesis and conclusion. Let's come up with an example and look at it over here. Okay, let's see. So, something that would be biconditional could be our first example again. So if you look at it this way, if you scored below a 60%, then you earned an F. Let's switch the green and the yellow, the conclusion and hypothesis. If you earned an F, then you scored below 60%. That is true. So I'm going to go ahead and switch and go to So notice I brought the yellow down here and the green up here. So we switched hypothesis and conclusion, and because this is true and the original statement is true, therefore it is biconditional. It is two-way true. So let's go ahead and look at some examples, and I think that's going to make a lot of sense. First, can we just write conditional statements? We're going to rewrite them in the if-then form. You can hit pause and try it on your own, or I'll do the first one, and then you can pause it, and then you can try the second. So a polygon with 6 sides is a hexagon. So I would write it this way. If a polygon has 6 sides, then it is a hexagon. All right, that's in the if-then format. You can try the next one. Okay, here I go. Press pause if you don't want to see it yet. A score of 70% or higher is passing. If you score 70% or higher, then you pass. Okay, that makes sense. So that's taking the time to write things in an if-then format. Let's go take a look at this next step. Validity. Validity, if we annotate, means truth. You can see the word valid inside. So if the statement is true, say so. Otherwise, disprove with a counterexample. So let's check the truth, the validity of each. If x is cubed, then the result is positive. Well, I need one counterexample. So if x is cubed, well, if I cube, let's say -2, that turns out to be, this here makes +4, but then +4 times -2, that ends up giving me a -8. So I just ended up cubing a value for x, and the result was not positive. Therefore, this is false. I proved it wrong with a counterexample. Let's look at number 4, or you can hit pause and try it yourself. Can you disprove it? Okay, the answer? Actually, you can disprove it. It is not always true. And again, the conditional statement has to be always true. If you take the absolute value of x, then the result is positive. Unless you take the absolute value of 0, which is 0, and 0 is neither positive nor negative. So this one was false, and so was this. All right, last one. Let's take a look here. So we're going for biconditional statements. Is the statement biconditional? How do you do that? You need to check the converse. Now, of course, the original statement has to be true. So let's see. If two angles form a linear pair, then they are adjacent. me see. We got two angles making a linear pair. Sure, they're adjacent by definition. That right there is true. Now, let's go ahead, highlight the hypothesis, highlight the conclusion, and now let's switch them. If two angles are adjacent, then they form a linear pair. Notice how I brought down the hypothesis and up the conclusion. We've switched them. We've done the reverse or the converse. Is this still true? If two angles are adjacent, do they have to always form a linear pair? And no, that's not true. I can think of a couple angles like this. Stick them together, angle 1 and angle 2, and they don't form a linear pair. They don't come close to making a line. So the second part here was false. So this is not biconditional. You can hit pause and try the next one. Okay, here I go. If an angle is between 90 and 180, then it is obtuse. We know that's true. So let's go ahead again and switch the hypothesis and the conclusion. If an angle is obtuse, then it's between 90 degrees and 180 degrees. And that does happen to be true. So we brought up that conclusion, we switched it with the hypothesis, and indeed this is also true. Therefore, this is biconditional, two-way conditionally true. Good luck.